So I don't know what protection was built in, because I haven't been told by NASA. They won't release it. They won't tell me the information. So if anybody has that information, how were the spacesuits protected from the radiation in deep space? Not talking about the Van Allen belts here, we're talking about deep space. Cislunar space, as Neil Armstrong refers to it, the space between Earth and the Moon. That has radiation in it. It comes from the sun, it comes from deep space. You have to be protected as a human. As an unmanned satellite, you can design the satellite to withstand the radiation. It's called hardening, where the electronics is protected, the electronics is shielded from the radiation, and that's quite easy to do. It's not so easy to protect humans or biological entities from it. Now, at some point, somebody's going to come up, well, what about Zond 5 then? Zond 5 was a Russian unmanned craft launched in September 1968 to orbit the Moon. And the Russians, being good chess players, put not only biological life, they put 2 turtles, I would call a tortoise or a terrapin, that sort of sized animal, some seeds, some biological plants, things like that. Sent them off to the Moon in the Zond 5, orbited the Moon, came back, landed. First time it had ever happened, by the way. First time a craft had ever returned from lunar orbit and landed back on Earth in one piece, because those 2 little turtles were still alive. Probably a bit pissed off, but glad to be home. So the evidence would appear to indicate that biological life can survive in the radiation environment in cislunar space, up to the Moon. Except when you then realize that turtles have an ability to survive thousands of times greater levels of radiation than humans can. So it's not a fair comparison. But what the Russians also did, I said they're good chess players, they played a very, very interesting game. They put on board Zond 5 a tape recorder with a recording of a cosmonaut. I don't know who it was, it doesn't really matter. And that tape recorder was switched on as Zond 5 orbited the Moon, and the voice of this cosmonaut came back saying, oh, I can see the lunar surface, I can almost touch it, it's so close, it's so beautiful, look at those craters, like as if there was somebody on board.
I'm still trying to figure out what the stuff about the radiation on the Moon. I'm trying to find the levels of radiation on the Moon to start with, the base levels.
Well, surely Apollo's got that, haven't they? They went there.
Just looking up what the actual...
Orion's first test flight, Exploration Test Flight 1, or EFT-1, was successfully completed in December 2014 along a trajectory traversing the peak flux regions of the Van Allen proton belt. The upcoming Orion mission, referenced to as Exploration Mission 1, is a test flight scheduled for 2019. It will reach cislunar space for a total mission duration of 21 to 42 days. The Van Allen proton exposure during EM1 is expected to be lower than EFT1, primarily due to faster transit through the belts, but significantly higher than that experienced by the International Space Station during South Atlantic anomaly passes. They tested a new method to detect radiation for future missions, and to do that, they went through the worst parts of the Van Allen belts consciously.
I just found the standing radiation levels on the Moon, and it's roughly 380 and 110. So that's much less than dangerous levels, it looks like.
I always find it fascinating when discussing the Apollo missions. The subject of radiation always seems to crop up as being either complete and non-event, don't worry about it, it's no worse than a couple of sunburns, or it's a major problem, it's the showstopper of space. These 2 viewpoints, that it's either a problem or it's not. And based on the evidence that I've read and seen and discussed and heard mentioned, that it's much more of a problem than people trying to diminish it claim.
It's a problem that you can solve. And when you solve the problem, then it's not that bad. One of the biggest problems with radiation in space is not as much of people and manned missions. It's actually unmanned missions and satellites. With the modern day electronics and how electronics are nowadays, the radiation affects that much, much more. It has a much larger effect on the satellite.
Let's just leave radiation aside. When Blue can do the research, I'll do a bit of research, but maybe we'll come back and have some more definitive answers. It's the EM2, which is going to orbit the Moon. That's supposed to be the next Orion launch. That will determine whether it's for real or not, because it's going to be watched very, very closely. But there is another problem in space which doesn't get discussed all that much until recently, And that's the levels of vacuum and the effect of vacuum on spacecraft and on humans and on equipment. The level of vacuum at the moon is severe. It's known technically as a hard vacuum, which is much harder than the vacuum at the ISS, and certainly much harder than any vacuum that can be reduced here on Earth, even at the Glenn Research Center in Ohio, which was used as the test bed. If you've got a very hard vacuum, you get two effects. You get liquids outgassing and you get metals cold welding. It's basically what it says on the tin. You put two metals together and they will literally weld themselves together, because the vacuum is so powerful at that point that it literally pulls out from the metal, starting with the more volatile elements and going down, the molecules of outgassed metals intermingle and join together, hence welding. Probably much worse than radiation, which you can protect against. You can't actually protect against the vacuum of space. It's all around you.
We've known about cold welding since the 40s.
It isn't new. All right, if cold welding exists, I think we can agree that it does.
Yeah.
In severe vacuum, in hard vacuum, how do any two metals, the helmet of a spacesuit is attached to the body of the spacesuit by a metal ring?
I've heard this a long time ago. I believe it when it comes from Earth, it has like a layer of oxygen or a layer of atoms around it that prevents the cold welding from happening. If you have two pieces of metal that were from space, then you will get it. But if you have metal from Earth, you won't.
No, those oxygen molecules will be outgassed in a vacuum with a form of Teflon. The Teflon itself actually does outgas, but it does protect the metals. One of the other major problems is, if that is correct, and I think we'd agree that cold welding is something which exists and can be demonstrated to exist. If you put any metals in space, they're likely to cold weld. For instance, the shutter of the Hasselblad camera is consisted of 6 individual leaves, not a curtain shutter. It's also within the lens of the camera.
Here's the prevention of accidental cold welding right here. You got your material selection, like coated surfaces. Selected materials can be coated, painted, oxidized, chemical, film, coated to reduce contact adhesion, so you can reduce actuator dependency, secure passive structures, cleanliness, lubrication, reduce contact surfaces, and reduce environmental exposure. There's a paragraph on each one of those topics sitting here, but that's just how you typically address cold welding.
At what level of vacuum?
In space.
Where in space? ISS level?
And the difference in vacuum between the ISS level and on the moon is not extremely different.
It's 3 times higher.
So what? It's 3 times higher than 1.
Vacuum levels are measured in what's called torr, named after Evangelisco Torricelli, who was an Italian scientist who developed the barometer back in the 1600s. Named after him, a torr level of vacuum, you get 0 at sea level here on Earth. At the ISS, you get torr 10 to the minus 6, hence the Glenn Research Center. On the lunar surface, you get torr 10 to the minus 12. Now, each level of that, 1, 2, 3, is 10 times. It's a logarithmic scale.
I know how a logarithmic scale works.
Right. So if you've got 10 to the minus 6 going to 10 to the minus 12.
So it's still a very tiny amount, because you're talking about tiny decimals. Tiny decimals. Saying that it's 3 times larger, it's insignificant.
Well, if you say so, I don't agree with you.
That's just math. And they're separated by 0.000002 of a unit. The separation is tiny. It's just that the difference of them is 3 times the amount. It's relative.
It is relative. What I'm saying is that the level of vacuum on the moon is greater than the level of vacuum at the ISS.
And then what I'm saying is that difference is basically irrelevant when we're talking about cold welding and we're talking about in space.
That's an interpretation you put on
Not an
it.
interpretation. That's what the difference is. The difference is minuscule.
Well, if you say so.
It's like 0.11 zeros and then a number.
Yes, 10 to the minus 6 is 10 with 6 zeros.
And the difference between 10 to the minus 2 and then the same number with a 6, was it?
10 to the minus 2 is 100. 10
Wait,
to the
hold on.
minus 3 is 1,000. 10 to the minus 5 is
Hold
100.
on. Are you going 10 to the minus 2, or is it 2 to the minus 10? So I thought you said the first time.
If you start at 10 to the minus 3 level at the ISS, you then go to 10 to the minus 12 on the moon.
Okay.
You're going up.
Those the numbers?
Yes.
That's not 3 times difference.
It's tens of thousands of times difference. That's the problem.
So where do the numbers come from that you said it was 3 times difference?
This is what I said right at the beginning. We're talking confirmation or falsification. You can confirm everything that you want to confirm. I don't have a problem with that because it makes for a very interesting discussion. If we all agreed on the same thing, we'd go nowhere. I'm trying to falsify much of what you're saying. Obviously without a great deal of success at the moment, because you're not agreeing it any more than I'm agreeing with very much of you falsifying what I'm saying. It's just that there are two aspects of this particular problem. There probably won't be a definitive answer. There probably won't be anybody who can say, okay, I get it, this is the answer. There probably won't be that, because people are so invested in the Apollo story that I doubt very much if you could.
All right, so the vacuum difference on the moon is 3 times 10 to the negative 15 atmospheres. So that's 0.3 nanopascals. And the atmosphere in low Earth orbit is 10 to minus 7 is required. But on the moon, it's ultra high vacuum, low Earth orbit. Here we go. 5 times 10 to the negative 10. That's not that big of a difference. That's still extremely low torque.
And how does that compare to the lunar surface?
That would be, I think it was 3 times 10 to the negative 15. It's not that big of a difference. There's still, we're talking point. That means is 100,000.
Compared to.
Between the two is 100,000.
And on the moon, it's God knows what, 15 zeros?
The difference between a 15 zeros and 10 zeros, to hit math on my top of the head, which I haven't done this in a while, should be 100,000.
100,000 is not tiny in terms of logarithmic scale. It's not tiny. It's big. It's huge. It's vast.
No, it's not.
That's not the same way as doing a logarithmic scale measurement. 100,000ths is still quite a lot more than 1/10,000th, which is the difference between 4 and 5 zeros.
The actual difference, the difference between the two numbers is 100,000th.
When it comes to vacuum, that's significant.
Is it now?
Yes, it is. When Apollo was being developed, they had a total budget of about $25 billion in 1970 terms. Okay? 10% of their budget was spent on vacuum testing at the Glenn Research Center. It cost $1.6 billion to build the damn place because they had to make sure it didn't collapse. It's quite big. It's got 8-foot thick walls. It's got a huge parabolic steel dish underneath it. A vast amount of expenditure went into the vacuum testing, not the equipment, not the rockets, not the landers, not the spacesuits, not the training for astronauts. They got shipped off to Hawaii and Vegas and wonderful places like that. They spent the money on building their vacuum testing chamber. Why bother if there's no problem about vacuum? There is a problem about vacuum. And this is one of the things which Apollo had originally demonstrated, because the Glenn Research Center was built before anybody had been out to the moon. They had to work out how to get there. If there wasn't a problem with vacuum, why build something that costs about 10% of your budget? It makes no sense. Any more than a lot of other things don't make much sense when you start examining it unemotionally, scientifically, and from a numerical point of view, which is what I try to do. I concede that some of the things I propose may not stack up because I haven't got all the information. You've obviously got a great deal more information about some things, and I'll listen to what you say because you may well teach me some important and valuable lessons. I hope you do. Similarly, I would hope that some of the things I say make a degree of sense to you and can be taken as something which is a logical progression. Now, if they don't, and if you don't take anything I say as having any validity at all, we may as well end the conversation right now. I don't think we should, because I think we can both learn something. I always consider that I can learn something from anybody I discuss this subject with. I'm not arrogant enough to think that I understand everything to do with it. If I'm wrong about radiation, if I'm wrong about vacuum, then I want to find out. But I've gone into it in a bit of detail. I do know what I'm talking about to a certain extent. I'm not a complete idiot.
But when it comes to the evidence, as I said, I mean, the visual library, I'll stick with that until someone can show me how in the world the sets were lit.
Okay, I've got it. This is what you do. This is your mission, should you choose to accept it. Watch Make-Believe Smoke and Mirrors. They use the Apollo film record. And they deconstruct it. They show you why the inverse square law, it certainly applies. I'm not saying that the inverse square law is irrelevant. The point is that if the sets on which the scenes are shot are models and miniatures, you don't need that much light.
Okay. They would need to provide evidence of it being in a model.
There is evidence.
The only way that you can line it is if it's a model, and you have to have hard evidence of it being a model, because that's an outrageous statement. This is the vacuum measurements on the lunar surface. So it says here, the vacuum quality at the landing site is much influenced by the absorption of the rocket gases and the later release. During the surface operations by astronauts, the pressure was near 10 to the minus 8 torr. No data were obtained between the time of the surface operations and lunar sunset about 12 days later, at which time the temperature fell rapidly to the vicinity of 100 K. The pressure was about 10 to the negative 12 torr shortly after sunset. But intermittent release of gas, perhaps from within the moon itself, occasionally raised the pressure by less than an order of magnitude for as long as a day or two at a time, and on one occasion to about 10 to the negative 10 torr for about an hour. So it looks like the pressure on the lunar surface fluctuates between 10 to the negative 10 and 10 to the negative 12. As the 10 to the negative 8, I believe, was influenced by the gases from the rocket.
Yeah, could well be, but that would indicate outgassing, which we know happens on the moon. As the sun covers the lunar surface, the temperature increases, the rocks expand, there would be an expansion of the gases within the lunar surface. Fair enough. That's logical. That's physics.
And then we have in low Earth orbit, the hard vacuum of space is 10 to the negative 6 to 10 to the negative 9 torr. That's coming from the JSC Space Environment ISS mini book from 2015. They expect it to be 10 to the negative 6 to 10 to the negative 9. And now we're talking about a difference that's even much less significant than what me and you originally talked about.
I would still claim that 10 to the negative 6 represents a million. 6 zeros, a million.
A million and billions, and not millionths and billionths.
They're a million times and a billion times higher.
It would be 4 times higher. Actually, it really wouldn't. 10 to the negative 6, if we're going to roll with the 10 to the negative 6 number and then roll to the 10 to the negative 10th number, so that's 10,000th different. But that's still a 10,000th of a difference.
Which indicates a higher level of vacuum.
By a tiny amount, by a 10,000th.
No. Well, if you say so, I just don't agree with you. That's all.
Okay. All right, let's move on to technology then, because that's something I wanted to talk to you about. You always have that one analogy. Do you mind repeating that analogy for the audience that you like to do about the Saturn V rocket?
The analogy was in the acceleration of the Saturn V rocket, and I was comparing it to the acceleration of a well-known car, say a Ford Fiesta with 100 horsepower. It could get from 0 to 60 in, let's say, 10 seconds. If you take a Ferrari 458, which weigh about the same amount, maybe the Ferrari's a little bit more, but it has, say, 500 horsepower, and it can get from 0 to 60 in 4 seconds. It's the power that is available to propel the vehicle forward that reduces the time. Now, the analogy with the Saturn V rocket is that it is possible to measure the speed at which the Saturn V rocket took off, because we know how far it traveled in a certain distance. Because of the cloud cover at the time, it was about 30,000 feet, about 6 miles up, and you can measure the time it takes the rocket to reach that cloud level, because you can see its shadow cast onto the top surface of the cloud as it punches through it. It doesn't appear to be traveling fast enough to be able to reach the speed that it allegedly reached to get into low Earth orbit, because the rocket has to achieve a certain speed to reach low Earth orbit. Otherwise, it will just fall down because gravitational attraction will pull it back. The main problem with that is that if it wasn't going fast enough to reach the orbit speed we're told it did, what was the problem? Was it the engines were not producing the power that we're told they were? Was there less weight on board? Or was there the right amount of weight but less power in the engines to propel it fast enough to get into low Earth orbit? If it didn't get into low Earth orbit, or if it didn't get into the right orbit, it may have got into an orbit about 100 miles up. But would that be sufficient to then circle the Earth twice and ignite the third stage for TLI, translunar injection, to accelerate the rocket to 25,000 miles an hour to escape velocity? That is the problem. That is what has been raised as a serious question. All I'm trying to do is to illustrate the problem that we've got with the acceleration of the Saturn V rocket. There's one other interesting little aside about the Saturn V rocket. Have you ever seen a film, television recording film, of the Saturn V rocket taking off and hearing it break the sound barrier?
No, I addressed this last time me and you talked on a different channel. We see it break the sound barrier. I believe I showed a picture of the Saturn V rocket in the middle of a sonic boom, in which sonic booms are visible things that you can see. The rate of acceleration is accelerating itself as the rocket goes up. It's not one uniform rate of acceleration as you would expect for something that has gears. The rocket itself is losing weight as it goes up into the sky because it's burning fuel, which means that its rate of acceleration is also accelerating. I don't really know what you are complaining about when all you've got to go on is it looks like therefore it is, I believe is what you're running on with that. And I don't really know what the complaint is here. I realize that you're saying that it's not going fast enough to reach low Earth orbit, but I don't see what evidence you've got to show that per se.
The malfunction of the F1 engine.
What malfunction of the F1 engine?
It wasn't producing enough power because it couldn't, because if it produced the 1.5 million pounds of thrust we're told it did, the cooling required to keep the engine in one piece was inadequate to do it. One of the problems with the cooling was that the metal used, it was an aluminium alloy, because the fuel was circulated around the skirt of the engine to cool the skirt and part of the engine before the fuel was then injected into the injectors. I mean, we're talking thousands of gallons of fuel per second, if not a few tons per second. It was a massive undertaking to get it into the rocket and ignite it. If you didn't ignite correctly, because it wasn't flowing accurately, you would get what occurred on Apollo 6, the pogo effect, the jumping up and down.
It says that pogo effect wasn't affixed.
They came up with a fix. They put an explosive charge in the combustion chamber.
I know what this is that you're using, and this is Randy Walsh's stuff. Randy Walsh is kind of running on nothing. He's running on some report made by some Russian at one point, and that report itself is not really running on anything. I would love to see something that definitely tells you that the rocket engines on the F1s weren't running at full power when they were launched.
The speed of launch would indicate that. Now, I don't think you can deny that the Russian scientists who wrote the report, I don't think you can say that they don't know what they're talking about, because they do.
All I've ever heard is just Russian scientist, and I looked up his name once, and I found literally nothing on the guy.
If you're going to talk about this subject, there are certain websites you do need to go to, whether you like them or not. The references are there. It's the owlist.com website. That's where the report is published.
All the places in which these reports are published are same places that have complete BS.
That's your opinion.
They're the same guys who complain as to why they had to open up 2 doors to get into the capsule when it launched and only had to get out of 1 door when it landed.
That's not on the Owlist website. I know what you're referring to. It was a misreading, but it's not on the Owlist website. So don't claim that it was. It wasn't. It was on a completely different website. So to lump all these websites that you don't like together does a complete disservice to a lot of people who've put a lot of time and effort into the subject. I think you should start taking a bit more notice of what they're saying.
Why is he only published on Alice websites? Why is he only published on websites that believe that the moon landing was fake?
How do you know that is the only site he's published on?
Anything on it anywhere else, and the only people who mention anything on it are you guys.
And what's the problem with that?
It cannot have two sources, and I can't even find anything on the Russian scientist.
Maybe he's not using his real name.
Why is he not using his real name?
Because of the sort of business that you've just described.
If he's using a fake name, then how in the world can you verify who he is and verify his attributes?
I don't know if he is using a false name. I'm just putting it forward as a suggestion. But you say you can't find him. You obviously haven't looked. I'll find it for you.
First time I was given this report, I looked up the guy's name. I didn't find anything on him.
So obviously you don't fully go along with all Randy is saying.
Randy,
have you read his book? Blue, answer the question.
The bits that are free online of his book, oh man, I thought about covering it once, but I found better topics to cover. But I did read what the bits that are online, and it's just poor, is what it is. He would not give me the free link to his book, and I'm not going to pay him money.
That tells you all you need to know about your level of research, that you're not prepared to pay any money for it.
So that's more of a principle. Out of the things that he said to me over email chain, which I will not release because I don't want to release emails, but after the things that he said to me, no, I'm not going to pay him money. Things that he's called me and the way that he's treated me and the way that he's talked to me, I'm not giving that man any money.
That's between you and him.
So you can't criticize me on my research level if me trying to research a subject that honestly isn't that big of a deal requires me paying money to a guy who's personally insulted me. Sorry, that's not a thing that you can criticize me on.
It's entirely between you and Randy. The arguments that you may have, that gets to personalities. But if you haven't read the book, you wouldn't be able to make that decision.
I've read the bits that are online.
That's not enough to do it. You've got to do the proper research.
What makes you think I haven't done proper research? Here's all of our websites that you got to do the research. What makes you think that we haven't read bits from these websites? What makes you think that we haven't seen all of y'all's videos? That we haven't been doing all these things?
But which videos have you watched?
Which videos have I watched? I've watched multiple of Randy Walsh's videos. I've actually seen every single video on his channel at least once. I've sat there and watched through them. I've watched the Apollo Detectives podcast that you're on all the time. I've watched 2 of those. I watch a lot of the Shill Stompers channel. I'll check in on that every now and then. And then I've seen 4 or 5 full-length documentaries on the subject, including the one on the ILS website, including the one made by Bart Sabrell. That's just on y'all's research. When it comes to the NASA researches and stuff like that, I have traveled to locations. I have read the entirety of the moon lander and the lunar rover's manual. I have just sat down and just grabbed documents from a shelf because we have 3 shelves worth of NASA documents at my UAB's library. Every now and then I'll just sit down and just grab documents off the shelf and start reading them because I find them very fascinating. And when it just comes to general conspiracy theory, I watch a bunch of general conspiracy theory documentaries as well. So to sit here and say that I need to do my research, it's very insulting. And it's just something that you always just go down to. Virtually every form of conspiracy theorist, they always just result to, just do your research. I have done the research.
Well, so have I.
Just because I don't know this one small thing that you know, doesn't mean I haven't done my research.
Yes. Okay, go on.
All right.
The article on the F1 engine is by Gennady Ivankov, PhD, and the Bauman Moscow State Technical University. Graduated from there in 1974.
So he graduated there under the Soviet rule.
Yep, majoring in aircraft engines specialization. Gennady holds 7 US patents, fiber optic sensors and switches. That's one of the articles. And the full paper, I believe it's about 50 pages long, the original article, which is what Randy's based a considerable amount of his chapters on the F1 engine on. So if you can find anything on that, be interested to hear. One of the points he makes is, consequently, the pressure in the F1 combustion chamber is likely to have been significantly lower than stated due to fundamental shortcomings in the tubular cooling system of the F1 engine. And that is below a picture of an F1 engine at the bottom of the Atlantic Ocean, which I believe was recovered by Jeff Bezos and is now in Seattle Museum. So you can go and look at it. But it's the cooling system which caused the problem.
Okay.
So that's part of the article by Gennady.
All right.
Did the F1 rocket engines correspond to NASA's published data? And was there a fundamental design flaw in the F1 engine? That's the start of the article. And basically comes to the conclusion, yes, there was. But the original article on which this is based is much longer.
Okay, then how was it with the F1 engines on the test stands? We did get the maximum output without pogo oscillation.
This is a point Randy makes in his book, that doing a static test of an engine is not the same as the engine under flight conditions.